Okay, so remember when we are going to be adding and subtracting radicals today, and it's kind of like just adding and subtracting like terms. The only things that you combine are the coefficients of the like terms. The key thing to make sure that you pay attention to are your radicals simplified. If they're not simplified, do that first and then see if you have like radicands. If you do, then you can add or subtract the coefficients. So let's do a couple of examples. Directions are just going to say simplify. So we're going to start off easy. 2 and radical 7, 2 radical 7 plus 6 radical 7. And what you should notice is that they both share a radical 7 in common. So if you factor that out, you just have 2 plus 6, which gives you 8 radical 7. So what made this problem easy is that they already had a common radical. Alright, let's do another one similar to that. We'll have 2 radical 3 plus 3 radical 3 minus radical 3. So if you notice, they all have the common radicand of 3. So that says go ahead and take the coefficients. So that gives us a 2 plus a 3 minus, and remember, if you don't see a coefficient, it's always 1. So minus a 1, and then radical 3. So 2 plus 3 is 5, 5 take away 1 is 4, and we get 4 radical 3. Alright, let's try one more here. We've got 3 radical 5, oops, try that again. 3 radical 5 minus 8 radical 11 minus 7 radical 11 plus radical 5. So if you notice, you don't have all the same radicands, but we do have some matches. For example, we have 2 with a radical 5, and we have 2 that are a radical 11. So we can put our radical 5s together, and that's a 3 plus a 1 radical 5. And we can put the radical 11s together, and that's a negative 8 and a negative 7 radical 11. And then we just do the math. 3 plus 1 is 4, so we get 4 radical 5. Negative 7, or negative 8 take away 7 is negative 15 radical 11. And there's nothing more we can do. Our radicands were simplified, and we are done. All right, we have a couple more complicated ones. So we've got number 4, and we have 2 radical 8 plus rad 2. So at this point, it doesn't look like we have matching radicands, but if we look for perfect square factors of 8, 4 can go in, and its partner is 2. So what we're going to do is have the 2 out in front, take the square root of 2 as another 2 out in front. Can't take the square root of 2, so we'll leave it as square root of 2, and then write out the rest of the problem. So simplifying, we get 4 radical 2 plus radical 2. Now that we have a match with our radicands, we can go ahead and combine up the coefficients. So 4 plus 1 radical 2 gives me 5 radical 2 as the answer. Alright, let's try another one like that. Ooh, more complicated. We have radical 10 plus radical 2/5. Now radical 10 is simplified. It's the radical 2/5 that we're going to have to work on. So first, we're going to rewrite, that should be a plus. Rewrite radical 2/5 as radical 2 over radical 5. And then we talked about how we can rationalize a denominator by multiplying top and bottom by whatever that denominator radical is. So now that gives us radical 10 plus radical 10 over 5. And this is when we kind of copy what the book was doing a little bit. We're going to pull out the coefficients, and the coefficient of the first one is 1, but of the second one, it's 1 over 5 radical 10. So we pull out the coefficient of 1/5, and then we're not going to say this is 1 1/5 because that one makes sense, so we're going to rewrite 1 as 5/5, add it to 1/5, so that we have an improper fraction. And we can write the answer either this way, or 6 radical 10 over 5. Okay? Let's see, I've got another one like that. I think we can fit it in here. So this was 9 radical 7 minus 14 times radical 1/7. So the 9 radical 7 stays, and we're going to rewrite this as radical 1 over radical 7. Now I can do the square root of 1, but what I'm going to do is rationalize the denominator by multiplying top and bottom by radical 7. So now I have 9 radical 7 minus 14, and now I'm going to have radical 7 over 7. Now what you should notice is that we can do a little simplifying, because 7 goes into itself once and into 14 twice. So our problem is, oops, sorry about that. Our problem is 9 take away 2 radical 7. And we end up with an answer of 7 radical 7. Alright, I got 2 more, and of course they're going to be our toughest ones. Number 7. We've got 5 radical 3 plus 3 radical 3/5 minus radical minus come on pen, radical 5/3. Alright, so not much we can do with the 5 radical 3 right now. But we're going to look at this as radical 3 over radical 5. And again, we have an issue here with leaving a radical in the denominator, so we're going to multiply top and bottom by radical 5. And then on the next one, we're going to make it radical 5 over radical 3. And again, we're going to rationalize the denominator by multiplying top and bottom by radical 3. So we still have 5 radical 3, and now we have radical 15 over 5 minus radical 15 over 3. And again, we can't simplify these last two fractions because the 3 is a rational number and the 15 is an irrational number, so we can't actually have them work together. So 5 radical 3, poor guy, has no friends. He's all by himself, lonely dude. But we do have the other two have the same radical. So what we're going to do is pull out their coefficients and do the math with them. Now they don't have a common denominator, so I'm going to work on that just right below them. Let's do it in a different color. So my common denominator for 15 and 3, or 5 and 3 is 15. That means I'm going to be multiplying 5 by 3, top and bottom, and this guy by 5 to get what I need. So this new numerator is 3, and then the other numerator is 5. And remember, there is a subtraction between them. So we still have 5 radical 3. And then we're going to have 3 take away 5, which is a negative 2/15. And then radical 15. And actually, we can be done right there. An alternative would be to have 5 radical 3 minus 2 radical 15 over 15. Okay? I've got one more. I think we can do them right here. And we've got radical 6 minus radical 2/3 plus 5 radical 12. Okay, so we've got a lot of stuff we can work on, except for poor radical 6, nothing we can do to him. For the second guy, we're going to split him into radical 2 over radical 3, and then we're going to clear out or rationalize the denominator by multiplying top and bottom by radical 3. On the next guy, we're going to come up with the perfect square factors of 12. So we've got a 4, and his partner would be 3. Okay, let's keep going. So we have a radical 6 minus a radical 6 over 3, and then plus 5, and then we take the square root of 4, comes out and it's a 2, and we can't take the square root of 3. So we've got radical 6 minus radical 6/3 plus 10 radical 3. So two of the guys have the same radicand. That would be the first two. So we're going to go ahead and pull out their coefficients and do the math. And we have 1 minus 1/3 radical 6 plus 10 radical 3. And 1 take away 1/3 is 2/3, so I get 2/3 radical 6 plus 10 radical 3. And that's as far as this problem can go. Now I do have one alternative to how I can write the answer. I can write it as 2 radical 6 over 3 plus 10 radical 3. All right, that's it. Good luck with your homework.